guys, this is Priyanka, Assistant Professor, Department of CSC. Today we are going to see the topic of bus structures. Already we see the function units in last session. Today the sessions of bus structure. Okay, what is a bus structure? It is just a communication pathway that connects the different components of a computer, that is a CPU, memory, input-output device. And also it allows the data, address and control signals to flow between them. For example, think of it as a highway where cars, that is the signals, travels between the cities, that is the components. There are types of buses, that is known as a data bus, address bus and control bus. Data bus is nothing but it transfers the actual data between the CPU, memory and input-output device. Address bus is nothing but it is a carries the address location of the data or instructions. Control bus is nothing but it carries a control signals that manage the operations. That is here gives a data bus carries actual data, address bus carries a memory address and control bus carries the control commands like read, write, etc. Deeply we see means first it transfers the actual data between the CPU, memory and input-output. And it is a bidirectional, that is our data can move both the ways. Here size, that is a bit of the bus, decides how much data can be transferred at once. For example, 32-bit or 62-bit like that. In address bus is nothing but it carries the address, that is the locations of data or instruction. It is a unidirectional, is only from CPU to memory, that is the input-output device. And also to determine the maximum memory the system can address. For example, we take a 32-bit address bus, that means 2 power 32 is equal to 4 GB addressable memory. And we move for a control bus. It carries a control signals that manage the operations. For example, we take a read, write signals, clock signals, interpret signals. And also it ensures that proper timings and coordination between CPU, memory, input-output device. Here we see the diagram of the computer organization, that is a bus structures. First we give a CPU, memory and input-output device. In these system bus, control bus, address bus and data bus are all connected to the processors. This is the diagram of the bus structures. We already see that a bus structure is a communication pathway. There is a single bus structure used one shared communication line, that is a bus, to transfer data and control signals between the various components of the computer system. That all devices connected to the bus, that we use the same set of lines to transfer the informations and from the processors, memory and other peripherals. These are the things comes under the bus structures. In this, there is a single bus structure out there and multiple bus structure out there. Single bus structure is nothing but it's only one common bus is shared to the CPU, memory and input-output device. And it is a simple, cheap, but only one operation can happen at a time. That is a bottleneck. But in multiple bus structure, it separates the buses from memory, input-output and CPU. And also it allows the parallel operation, that is faster. And also it more complex and expensive. In short, we want to see that the bus structure is the backbone of the computer communications. That is, data bus does the carries the data in the system, address bus does the carries the control signals to the memory, CPU, input-output device, and control bus is carries the control signals. That is, it can be single, simple but slow, or multiple but fast, costly. And also we see the diagram like a CPU, input-output device, memory, all that occurs into the peripheral device. Other peripherals like a processor, memory, these all comes under the bus structures. In next video, we see what is a single bus structure. In the single bus structures, what are the things we can able to do in this processes. Like that we see in the bus structures.